In this video, I'm going to show you how to use the PIO to control the 7-segment displays the way I would to display decimal numbers on the 7 segments. So first, let's go and open up our pre-existing system in Windows Explorer. Let's copy it and rename it to System 7 or System 8. Let's open it up. The Quartus project file. Now that it's open in Quartus, you can see this is our previous built system. We're going to open up Qsys and open up our System 8 Qsys file. We're going to search for PIO, Parallel Input Output. Double click on it to add. We're going to come here, and since there's 7 segments on a 7-segment display, we need 7 bits, 1 bit per segment. We don't need any edge capture or interrupts for this since it's an output. We can finish. Come down here, rename this by right click, rename, and let's name it 7_seg0. There we go, 7seg0. Let's connect our clock to our clock, our reset to our clock reset, and our JTAG reset, S1 to just data master, and export our external connection and call it 7seg0. This is just for one 7-segment display. The DE2115 has 7 7-segment displays. So what we're going to do, instead of adding a PIO every single time, every single one needs to be set up the same. So right click, duplicate. And hey, how'd you know? It named it the correct file name I wanted. Do that again. So we get 2. So now we have 3 of them total. Right click, duplicate. We have 4 of them. 5 of them. 6 of them, or 7 of them. Yep, no, there we go. So we have 7 of them. 1, 2, 3, 4, 5, 6, 7. Now we're gonna have to come through and make the connections in all of these. We're gonna make all these connections the same. So clock goes to clock on every single one of these. Our reset goes to our clock reset and JTAG reset on every single one of these. Our S1 will go to just data master on all of these as well. And we need to export all of them as well. 7-segment 1. 7-segment 2, 7-segment 3, 7-segment 4, 7-segment 5, and 7-segment 6. Now let's come down here and take a look at our errors. It's telling me that all of these are overlapping. So now they are not locked, so we can go to System, Assign Base Addresses, and all of those errors just went away. Let's take a look at our warnings, or our messages I should say. These are not warnings. And everything is as it should be. Let's save this and generate. So go up to generate HDL, Verilog, create block system file, BSF, and generate. And it says generate complete successfully. Good, no errors, no warnings. Easily get them all by clicking those. Close, minimize Qsys. Back in our Quartus project, we're going to double click under project, Nios II system, click OK. I want to add this. I'll line it up, so make sure our clock goes to clock, green LEDs to LED G, key 1, key 2, key 3, red LEDs, key 0 for the reset, DRAM SDRAM, all these are good. And here's where we have problems. Okay. Let's delete all these connections. Select these, and these need to come down here. Let's reconnect our switches, our SRAM, alright, and now since these are all purple, they're all outputs, so we need to add an output. And again, these outputs are facing the wrong direction, so we want to flip them and add them. We're going to copy it, paste it, alright. Let's connect all of our 7 segments, going from our device to our pin, so we get the correct conduit. And now let's name these. And the 7 segment displays are called hex, so HEX, open bracket, 6.0, close bracket. And oops, forgot something here. They're hex, so this is going to be hex 0. Be hex 1, 6.0. Hex 2, open bracket, 6.0. Hex 3, open bracket, 6.0, close bracket. Oh, wrong type of bracket. On both of these, it can be square brackets, not curly brackets. Hex, what am I on? 4, open bracket, 6.0. Hex, open bracket, 6.0, close bracket. Yeah. Forgot it's hex 5. This is hex 6, open bracket, 6.0, close bracket. All of those look correct. Alright, save this, and now let's compile. Quartus II full compilation was successful, 0 errors, 386 warnings. That's good, that's what we want to see. Let's come over here and double check, make sure all of these pins were assigned correctly. And it looks like they are. That's good. You want to take a look at my tutorial for the Nios II processor and Nios II dev tools that takes an integer and converts it to the 7 segment code that needs to, so that these 7 segment displays can display the correct integer number that you want it to show. This system files and written documentation for this system can be found at fpga.seanwrel.com. Go there, you can download this actual system that I have built. You can download documentation for it. You can also read the documentation right on the website and watch this video.